Welcome to a short video showing you how to deal with non-whole number mole ratio coefficients in empirical formula analysis. Alright, so in class we've already dealt with how to determine from grams of sample the mole to mole ratio of elements in empirical analysis. So I'm giving you a couple of examples down here to look at. Okay, this we've seen already, where after you divide through by your lowest mole amount, the mole ratio, right, the moles are these, right, there's a 1 here, the mole ratios are whole numbers. That's great, makes your life easy. This is the empirical formula. But come over here and look at this value over here. Do you see the carbon is 1.2? So even after dividing through by oxygen's lowest number of moles, which gave it 1, all the other variables, hydrogen was fine, it was a whole number, but carbon is 1.2. We cannot have fractional mole amounts, okay? So we're going to have to deal with this number right here. We're going to have to find a multiplier that I can multiply the 1.2 by to make it a whole number. And in doing so, I'm going to multiply it also to all the other elements, the mole amounts here for the other elements. So we're going to scale up. Here's the table, table 1 right here. It lets you look at the fractional mole subscript, if you will, and it tells you a factor that you need to multiply. Now, this table is not going to be provided to you on a test, so you need to be familiar enough with it. And one of my suggestions is to assume that your fractional amount is kind of like money, okay? I think of 0.10 is 10 cents, 0.20 is 20 cents, 0.25 is a quarter, okay? How would you scale that up to $1 or to a whole number dollar amount? Well, if you have 1 dime, obviously you need 10 of them to make $1, so you multiply by 10. If I have 20 cents, I'm going to need 5 increments, or five multiples of 20 cents to make $1. There's my by 5. 25 cents, obviously, it's a quarter. You need 4 of them. Okay, 0.33, multiplied by 3 to make a whole number. Okay, this is one, it's interesting, 0.4, 40 cents. Well, there's no multiply that's going to let me equal $1, but if I want to try to extend that out, think about multiplication tables. 4 times what gives you an even whole number? 4 times 5 is 20, so 0.4 times 5 would be 2. So in that case, I think about multiplication tables. 50 cents, that's obviously, or 0.5, that times 2. 0.6 is not on your table on page 115, but 0.6, well, 6 times what multiplier multiplication tables gives me an even power of 10, if you will? 6 times 5 is 30, so 0.6 times 5 would be 3, and so on and so forth. Down here, 0.9, I added that in. You can multiply that by 10 to get 9. Alright, so let's practice this. Let's see if we can identify where we need to scale up. Here is an example. Let's say you divide it through by your lowest mole amounts, and it's oxygen, because you see it's 1, and I still have carbon as 1.33. Okay? What do I need to multiply that by to make it a whole number? So again, I'm looking at the 0.33. and I should multiply that by 3. And the minute I do that by 3, I multiply everything by 3. So carbon becomes 4, hydrogen becomes 18, and oxygen becomes 3. So my empirical formula would be, just bring it all together, this. Okay, let's try another one. So N, 0.40, hydrogen 1. Alrighty, well, it's obviously the 0.4, right? What are we going to multiply it by? 4 times what gives me a whole, even kind of tens value? I hope you're saying 4 times 5, right? And pull your calculator out. 0.4 times 5, if you don't trust your head, it's going to equal 5 nitrogens and, oh, sorry, I'm already messing up. And I did my calculator and still can't do this math correctly. Okay, it's going to equal 2. Okay, so my empirical formula is going to be N2H5. Okay, let's try the next one. Sulfur 1.6, hydrogen 4, oxygen 1. All right, my increment, my thing that I'm looking at here is this 0.6. Well, I know that 6 times 5 is 30. Okay, so 0.6. Let's try it. 0.6 times 5 should be 3. Pull out my calculator. 0.6 times 6 times 5. All right. I'm going to try times 5, and sometimes it's a process of elimination. If you don't give up, try again, but I'm going to get S8, H, 4 times 5 is 20, oxygen 5. So S8, H, 20, O5. All right, we have one last example. Oh, it's probably the easiest, but in some regard, I'm looking at this, and I can see that I have fractional amounts for 2 elements, okay? When this happens, they're usually the same fractional amount, so that way the one multiplier will make them be whole numbers. If you find out that you have 2 different fractional amounts, go back and check your math. Something's wrong. You're not going to be able to multiply through by one multiplier to make them be whole numbers, most likely. So I'm looking at this. I see a, come on pen, a 0.5 and a 0.5 here, right? So what are we going to do for scaling this? What are we going to multiply by? I hope you're saying 2. Your bells are going off in your brain for times 2. So 0.5 times 2 is carbon 1, right? Pull your calculator out. C1, H14, and N1. So C1, H14, N1 would be the empirical formula for this. All right, so remember, this fractional mole subscript can be handled by scaling up through multiplication of a factor. Okay, and you absolutely cannot have this going on. You cannot present an empirical formula with a fractional amount and for the mole subscript. You got to change it. And I hope this video helps, and thank you for your time.